Okay, so today we have composition functions. We are basically going to take one function and plug it into the other function for all values of x. So when you compose a function, well, I guess we should go over the notation first. So if you see this notation, it is read as f composed with g. So you can say f composed g. So looking at the next statement below, this says f composed g of x is going to be equal to f of g of x. So like I said, we're going to take a function and plug it into another function. So when you compose two functions, the function that you compose with, you will take its domain. So in this case, since it's f of g of x, in order to compose, f has to abide by g of x's domain. So f takes function g's domain. I compare it to Mortal Kombat. You take the function soul when you compose with it, if that makes it any easier. So when you compose two functions, you must take that function's domain. Your soul is mine. All right, so let's go ahead and practice the compositions and finding domain. So for example 1, we're given f of x equals x squared plus 3x minus 1, and g of x equals 2x plus 3. Find the compositions and the domains. So first off, it's always easier to find the domains of the functions that were given and then do the compositions. So f and g are actually polynomials. So this example is going to be really nice. What is the domain of all polynomials?
All real numbers.
Good. So f's domain is negative infinity to infinity. And g's domain is also the same. Negative infinity to infinity. So it's always good to find the domains first. Now we want to do decomposition f composed g of x. So we write it just as it was above. F composed g of x means f of g of x. So what we're going to do now is take g of x and plug it into the parentheses first. So we're going to have f of g of x, which is 2x plus 3. So we just make that quick substitution. And what we're going to do next is take all of this 2x plus 3 and plug it into function f for every single x. And we're going to simplify. So 2x plus 3 goes in for every x. So we're going to have 2x plus 3 squared plus 3 times 2x plus 3 minus 1. And now all we have to do is simplify. So 2x plus 3 squared has to expand to 2x plus 3 times 2x plus 3. You can distribute this 3 already, giving me 6x plus 9 minus 1. And then FOIL the 2x plus 3's. That should give me 4x squared plus 12x plus 9 plus 6x plus 9 minus 1. And now simplify and combine like terms. So we see that we only have 1x squared, so there's a 4x squared which will come down. And then I have a 12x and a 6x, so 18x. And then I have 9, 9, and minus 1. So 18 minus 1, we get 17. And here is our composition function. This is the f composed g of x. Okay, and like I say, when you compose with a function, you have to take that function's domain. Lucky for us, the domain of both functions are real numbers. So this means that the domain of this function is also going to be all real numbers. Okay, so that is the composition process. You take a function and you plug it into the other. You only simplify. We do not solve these. To solve means you set it equal to 0 and you keep going. For compositions, all we have to do is simplify. Any questions on that process? All right, everybody good?
One quick question I have is the problem going to tell us which one, like, we're supposed to take and plug it into where?
Yes. Well, I mean,
Okay.
it's gonna be set up just like this. So you're gonna be given two functions, and it's gonna tell you to do f compose g, g compose f, maybe even f compose f, and whatever else. But yeah, it's gonna tell you what the composition is or to
Okay.
do. Yeah. Okay. Which is like this next one. We are now gonna take function g and plug it into function f. Or no, wait, sorry. We're gonna take function f and plug it into function g. There we go. So this becomes g of f of x. So g compose f of x becomes g of f of x. And now we are going to substitute f of x in the parentheses, x squared plus 3x minus 1. And again, all of this is now going to go into function g for every x. So we are going to get 2 times x squared plus 3x minus 1 plus 3. And all we have left to do is simplify. So this becomes 2x squared plus 6x minus 2 plus 3. And then simplify. 2x squared plus 6x plus 1. Here's our composition. This is the composition function, g compose f of x. And again, since our domain was all real numbers, the domain of this function will also be all real numbers. And once again, we only simplify. We do not solve unless we're asked to. Students love to say that it's not finished, and they'll set the equation, or they'll set the composition equal to 0 and keep going. And I'm like, why? It didn't say to do any of that. So do not make this mistake. You only simplify, you do not solve. Okay, any questions on that first page? All right, then. Let's evaluate a composition function. So we can also compose and evaluate at a specific value of x. So for this function, you're given 2x squared minus 3 and g of x equals 4x. We're going to find the compositions, and after we do, well, I guess we're going to plug in, okay, 1, 1, -2, and -1. All right, so for A, we have f composed g of 1. So what we're going to do first is rewrite the composition, and it's going to be rewritten as f of g of 1. Okay, so what this is telling us to do is take 1 and plug it into function g for every x. So I'm going to do this down below. I'll just make a little side work section. And I'm going to figure out what g of 1 is. So g of 1 is just going to be 4 times 1, so we get 4. So that means we get to replace g of 1 with 4. So this now becomes f of 4, which means now we take 4 and plug it into function f for every x. So you'll get 2 times 4 squared minus 3, 2 times 16 minus 3, and 32 minus 3, we get 29. Okay, so that is how you compose and evaluate at the same time. Any questions on that? Do it again. I can see those functions. G of f of 1. Rewrite it. G of f of 1. So let's go ahead and figure out what f of 1 is. So again, little side work. We'll look at f of 1, and that is 2 times 1 squared minus 3. And that'll give me just 2 minus 3, or negative 1. So f of 1 is going to be negative 1. So we'll make that substitution. G of negative 1. And plug it into function g above. So you see that you'll get 4 times negative 1. So we'll just end up with negative 4. Okay. And then B, f of negative 2. So f compose f of negative 2. So rewriting that, we get f of negative 2. Okay, so again, we're going to take negative 2, plug it into the function f, and side work again. I'll get f of negative 2, which will give me 2 times negative 2 squared minus 3. That'll give me 2 times 4 minus 3. So we'll get 8 minus 3, which gives me 5. Okay, so 5 will be, so f of negative 2 will become 5. So this means we'll get f of 5. And then once again, we're going to take 5 and plug it into function f. Okay. So here you'll get 2 times 5 squared minus 3. And then 2 times 25 minus 3. So 50 minus 3, we get 47. Okay. And then D, G compose G of negative 1. Rewrite it. G of G of negative 1. Let's go ahead and find out what G of negative 1 is. And G was just 4x. So you get negative 4. Now that will replace G of negative 1. So you'll get G of negative 4 which will then give us 4 times -4, and we'll get -16. And that is composing and evaluating at the same time. And once again, we are simplifying. All right, any questions on that page? All right, everybody good? Okay. Example 3. So again, we are going to compose these two functions and find the domain of the composition. So for example 3, we're given f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1. So before we even compose, let's find our domains. What is the domain of function f?
Not -2.
There you go. And then what is g's domain? X can equal what number?
I've been muted, not 1.
1. There you go. Okay, so we have the domains figured out, which means we are ready to compose. Okay. So first is f compose g of x. Oops. Which means we get f of g of x, which means that you'll get f of 4 over x minus 1. Maybe I use a different color. Why not? 4 over x minus 1. Okay, so this is function g that we are now going to plug all of this in for function f in for x. Okay, so this is what we're going to have. 1 over parentheses 4 over x minus 1 plus 2. So we've just plugged it in to function f. And now we have to simplify. So this means that I need to clean up the denominator, which means I need to put 4 over x minus 1 and 2 together. So in order to do that, we have to change 2 into a fraction. You're going to put 2 over 1 and multiply by what common denominator?
X minus 1.
X minus 1. Okay. I'm sure I got a lot of room. Good. Okay. And now this will become 1 over 4 plus 2 times x minus 1 over x minus 1. And if you have a fraction in your denominator, you multiply by the what?
The reciprocal, inverse, or something.
Reciprocal. Yeah. So we just take this fraction and flip it over. So we get x minus 1 over 4 plus 2 times x minus 1. Okay. And now, since we made it look prettier, of course, we clean it up more because we have to distribute that 2 and clean up the denominator. So we'll get x minus 1 over 4 plus 2x minus 2. And our final composition, I think I still have room. Our final answer for this composition is x minus 1 over 2x plus 2. X minus 1 over 2x plus 2. Yes, we can factor out as well, just to make sure. This can also be our final answer, 2 times x plus 1. Okay. Yeah, let's make that our final answer. Let's change that up. This is fully simplified. Okay, so there's a composition. This is going to be f composed g of x. And now we have to find the domain. So looking at this new function, what is our domain that you see below?
-1.
X cannot equal -1. And now here comes the Mortal Kombat. Since f composed with g, we have to take g's domain. We take g's soul. What was the domain of function g?
+1.
So we have to include that as well. So not only can x not equal -1, x also cannot equal +1. You must take the domain of the function you are composing with. Any questions on that?
So once we discover the domains, we don't have to apply the domains to any of the other problems. We're just trying to discover the domain.
Say that again.
So once we find the domains of both function f and function g,
Like
as
we
you
did
read-
up here.
yes.
Yeah.
So no, I'm talking about the answer down there,
Mhm.
the -1 and 1. Do we have to plug those into anything specific in the problem, or once we discover that, that's pretty much it?
That's it. So once you have these, you don't have to do anything else with them.
Okay, understood.
It may, I don't think it will, but it could make you put an interval notation. If that happens, then your interval notation would just be -infinity to -1, union, -1 to 1, union 1 to infinity. Okay. All right. So there's that. And now we can do f composed with f. We're going to compose a function with itself. So first off, rewrite it as f compose f of x. And now f of x is 1 over x plus 2. So this is going to become f of 1 over x plus 2. So we're going to take 1 over x plus 2, plug it into function f for every x. All right. So this is what we're going to have. 1 over x plus 2 plus 2. Okay. So we've just taken f, plugged it into itself, and now we have to simplify. So just like the last one, we're going to put 2 over 1 and get a common denominator of what?
X plus 2.
X plus 2. Okay. And you get 1 over 1 plus 2 times x plus 2 over x plus 2. And again, you have a fraction in the denominator, so we're going to reciprocate it, or we're going to flip it. And we get x plus 2 over 1 plus 2 times x plus 2. Okay, so we reciprocated it, and now we simplify it. And we get x plus 2 over 1 plus 2x plus 4. Our final answer, x plus 2 over 2x plus 5. There's f, compose f of x. And now, domain. Look at the new function. And what would the domain be for this denominator?
-5/2.
Good. X cannot equal -5/2. But since we composed f with f, we also have to abide by functions f's domain. What was the domain of function f?
Not -2.
Not -2. Good. Not -2. And there you go. That is more practice on compositions, especially with fractions. Yeehaw. All right. Any questions on that page? Everybody's got it? Good for a Monday, huh? All right. Next example is showing that two composite functions are equal. So here we're giving f of x as 3x minus 4 and g of x equals 1/3 x plus 4. We want to show that f composed g of x is equal to g composed f of x. And what we want to, and the way we're going to show that is that when we compose them, we should arrive at x going both ways. And this will come into something bigger next class. Next class, we're going to learn about inverses. So this is just setting us up for inverses. But like I said, we'll get into that next class. For now, we're just doing the exercise of showing these two compositions are equal. So let's go ahead and compose the first way. We're going to do f compose g of x, which means we get f of g of x. So what we're going to do again is take g of x and plug it into f of x. But let me make that substitution real quick. Let me plug in g, which is 1/3 times x plus 4. Okay, so now all of this goes into function f for every x. So we get 3 times, I'll make it red still, why not? 1/3 times x plus 4 minus 4. Okay. So now you see that the 3 and the 1/3 will what? What is 3 times 1/3?
1.
1. Good. So that'll just leave you with x plus 4 minus 4, which leaves us with an answer of what?
X.
X. Good. So we have what we're looking for going one way. And now let's try it the other way. 2. We are now going to do G compose f of x. We get G of f of x, which then gives me G of actual f of x, make that substitution, 3x minus 4. And now take all of this and plug it into function g for every x. So we're going to get 1/3 times 3x minus 4 plus 4. Okay. And then this becomes 1/3 times, your 4s will cancel. So you'll get 1/3 times 3x. And again, the 1/3 and the 3 will what?
Cancel out. Make it a 1.
Make it a 1. So we're left again with x. All right. So by compositions, we have shown that f compose g of x and g compose f of x, they are both equivalent because we arrive at the answer of x. And again, what this leads into is on the next section, this will show that those functions are actually inverses of each other. So we're just putting in the composition work today. Okay. Any questions on that process? All right. 5. 5, we now work backwards. We're given a composition function, and it wants us to figure out what f and g are. And the answers could be many. So let's have fun with this. So number 5, find functions f and g such that the composition of f and g equal h. And h of x equals x squared plus 1 to the 50th. Okay, so our job, we'll call this answer number 1, is to find out what is f of x and what is g of x. So what are the 2 functions that could possibly make this composition function? So think about it. Give me 2 functions that could make this function. And don't overthink it. Just shout out an answer. We'll try it out.
Could it be like x squared plus 1 squared and then x squared plus 1 to the 25th?
So this is x squared plus 1 squared. And what was the other one?
I don't know. Some x to the 25th. Oh, actually, it was the other way around, I think.
Oh, switch these around.
Yeah.
Okay, let's try it.
I don't know.
Hey man, it's a good guess. Let's see. So this will be x to the 25th. And this will be x squared plus 1 squared.
Yeah.
Okay, well, let's check it out. F composed g of x means you get f of x squared plus 1 squared. And you plug that in and you get x squared plus 1 squared to the 25th. Well, good. Powered to a power, you multiply those, and what would we end up with? X squared plus 1 to the 50th. That checks out, man. Good. And again, that's one of many options. Let's try a second one. How about x to the 50th and g of x is x squared plus 1? Is that going to work out? So that one definitely checks out. All right. And now I'm going to give you guys the easy ones. Oh, man. So let me get rid of the check. Let's see. All right. 3. Let me get rid of those. 3. Watch this. F of x is x, and g of x is x squared plus 1 to the 50th. What do you guys think? Will that work out?
I hate you.
I was just thinking the same thing.
The hate. And then, well, if it's that simple, what's my last answer then? Take number 3 and reverse it. What can f of x be?
X squared plus 1 to the 50th.
And what's g of x?
X.
That's it. My goodness. There you go. You just got to think out of the box a little bit. Which means let's try it one more time. So here they give us the composition function 1 over x plus 1. All right. So what is my f of x and what's my g of x? You could even steal from my 3 and 4.
So f of x equals 1 over x plus 1 and g of x equals x.
That's simple as it could get. What's my second answer then?
F of x equals x and g of x equals 1 over x plus 1.
Yep.
God damn it.
All right. But now, what's another good answer? Now really think.
f of x equals x to the -1 and g of x equals x plus 1.
Wow. X to -1. All right. Take it. And that's x plus 1.
Yeah.
Perfect. All right. Good. Is there a fourth one? Maybe, maybe not. Let's see. Like I said, there's infinitely many answers for these ones. Oh, okay. I just did that. Perfect. So those are good enough. Any questions on this page? No. All right. Great. You guys are getting it. Perfect. All right. Let's move on to example 6. An actual math application. The surface area, S in square meters of a hot air balloon is given by S of R equals 4 pi r squared, where r is the radius of the balloon in meters. If the radius r is increasing with time t in seconds, according to the formula, r of t equals 2/3 t cubed, where time is greater than or equal to 0, find the surface area of the balloon as a function of the time t. So what have we learned today? What are we doing with functions?
Composing them.
We are composing them. So all we have to do in this equation is take the surface area and compose it with the radius formula. Nothing crazy, right? So this means that you'd get S compose R of T. And the reason T is because we are finding the surface area of the balloon as a function of time T. Well, this becomes S of R of T. And do we have a formula for R of T?
Two over 3t cubed.
There you go. So that becomes S of 2 over 3 t cubed. And now we take all of this and plug it into function S for R. Leave that there. And we get 4 pi times 2/3 t cubed. I'll keep it blue. 2/3 t cubed squared. And all we have left to do is simplify. Okay, so you'll get 4 pi. And what is 2/3 squared?
Eight over 27.
That would be cubed, right?
Oh, sorry.
So squared,
4
very good.
ninths.
4
4 over 9.
ninths. Good. And what's t cubed raised to the second? That's going to give me t to the what?
T to the 6th.
T to the 6th. Good. And now just multiply 4. You can put this 4 pi over 1 and multiply straight across. I'll get 16 pi over 9 t to the 6th. And there it is. This new formula will give us the surface area of the balloon as a function of time. So if you think about it, as the radius of a balloon is expanding, the surface area of the balloon is increasing. And it only makes sense, right? Radius expands, the whole balloon expands.
Does that take into account the temperature of the surrounding air.
No, that's physics. But that's how compositions work. All right. And what's cool is that you'll get into something once you hit calculus. It's called related rates, where one rate depends on another and they change with time. So with related rates, you can actually find the rate that the radius is changing at, and you can also find the rate that the surface area is changing at. But that's not for a long time, guys. Okay. So I think that finishes compositions. So yeah, we are done with 6.1.